Good morning, Ed. Good morning to the lab. We're working late this morning. It's about 4:50 a.m. What we're doing is that we're looking at the last IF transformer, which is not working properly. This is the last tube. The signal comes in and goes through the tube, and we're bypassing the tube. We're injecting our test signal into the output of the tube, which is the plate, through a capacitor, because it's got B plus on it. We're pumping it in through this transformer, picking it up on the other side of the transformer as a result of tuning it, tweaking it, and then it goes through the detector over to the audio amp. So we're checking out this transformer here. We're pumping a 455 kilohertz signal into this transformer to see if it works. So we come over here to the bench. Here's our setup. We've got the 3325B. We're sweeping from 450 kilohertz to 460. And we're sweeping right now, and the time that we're sweeping is 1 second. When we're listening, we get the volume almost all cranked up. We got it injecting into the circuit through that cap. We're pumping a volt in. It's pretty weak. I got the volume all the way up. I can hardly hear it. So, all right, let's put in 2 volts. Let's put in 2 volts. It's a little louder. How about 3 volts? It's getting loud. How about 10 volts? All right, that's loud. 2 volts. Again, we're sweeping from 450 to 460 with 455. Let's try this. 455 kilohertz. We're putting that in right now. Doesn't sound too good. 450, we'll go back up to 460 kilohertz. Sweep it. And the amount of time is 1 second. I don't hear much difference at all. So you say, all right, let me try sweeping it from 440 kilohertz to 480 kilohertz. Should be somewhere in there. Let's sweep it. It's sweeping. Now we start to hear it a little bit. Here it gets a little in. So, but that still is weird. We're not really hearing it. So you say, all right, how about if our start frequency is, instead of let's try 400 kilohertz. Uh-oh. Sweeping it from 400 to 500 kilohertz. That's weird. Let's see if we can time ourselves. That's where it's the loudest. That's 414. Wow, that's pretty low. Let's use this function and say, let's go down in frequency. Actually, let's go a little louder. Uh-oh. Yikes. Let's bring it down to a half a volt. This son of a bitch is getting hot. So at 367, oh my God. It's getting even louder. It's a quarter volt. 337, let's go down more. Okay, less. Up. All right, how about over here? Weaker. About there. Let me bring the volume down. All right, that's at 1 volt. Let me try it. It's at 10 millivolts. Can we hear that at 10 millivolts? Nope. How about 100 millivolts? Nope. Millivolts. Oh, I'm sorry. What was that? 380 kilohertz? 350 kilohertz? Let me just sweep it again. 300 kilohertz. Oops, clear. Our start frequency will be I think it's like 300 kilohertz, and we'll sweep it to 400 kilohertz. Sweep it. Time is 1 second, and our voltage is 1 volt. Wow. $342. Gets weaker. What that tells us is that this can here, or whatever's going on, it's not optimized for 455 kilohertz. It's actually peaking at 340. It's like, that shouldn't be. So let's set it to 455 kilohertz. You can't hear it. We'll pump in 5 volts. You can barely hear it. Okay. This is 455 kilohertz, which is what it should be, at 5 volts, which is way too much. We can hear it, but we're really jamming audio. And then we take a screwdriver, and the adjustment, I think, is this one. I think it's this one. It ain't doing jack shit. None of these are doing anything. No peaking is going on. Nothing. So that tells us something's awry, because if we go back down to 300, let's say, or sweep it. Let's bring the voltage down again. Let's bring it to 1 volt. Even that's too loud. In fact, that's the loudest that the AF amp gets. The audio amp is working really well when you get the thing. So this last stage right here, with this tube, a H7, after that, it goes through that last transformer, and it ain't happening. That thing is killing it. It's not that it's not working right, because on 345 or whatever it is, 345 kilohertz, it's good. But the other ones aren't tuned to that. These are 455, and when we pump 455 in, you can't even hear it. That's at 1 volt. But if we pump in 340, oops, excuse me, hang on, let me clear it. 340 kilohertz, 2 volts. Let me clear that again. 340 kilohertz. Let me get rid of that. 340 kilohertz at 2 volts. For some reason I can't hear it anymore. We'll do 500, 400, 300 kilohertz, 400 kilohertz at 2 volts sweep. It's not sweeping. What am I doing wrong? Anyway, you get the gist. What it means is that this PHILCO right here, that IF can is not, it's not the tube. We're after the tube. We're injecting in the output of the tube through this capacitor. We're injecting into that output of the tube and the capacitor into this can. Then it comes out of there and it goes through this to get detected and here to get amplified. It works really good at 340 kilohertz, but at 455, you got nothing. So if all the radio, whatever's happening from here, it goes all the way up and then it gets to here, and that keyhole, instead of it being on 455, it's down on 340, which means that there's something going on in here, which might be, let's see, it's the capacitance in the circuit is probably too, I don't know what, too big, too small. It's way off. Mica capacitor. Something's way off in there. So unfortunately, we're gonna have to operate, but not right now. That takes that off. That takes that off. That turns that off. Good night, Hirschberger. From the lab. Oops. Good night, Eddie boy.